Hello everyone, for those who are new in this channel, I am Engineer J. I am a civil engineer and I'm also a engineering professor. And in this video, I am going to teach you one of the most common topic in surveying, and we have here area computation. This topic is essential, especially if you are a surveyor, a geodetic engineer, a civil engineer, or if you are just a person selling a lot, if that is your business. Actually, in computing for lot area, we have a different approach. So one of common approach is by adopting geometry procedure or a trigonometric procedure. Now we actually compute for the area of a traverse by dividing it into triangle. Okay, that's the most common method. So if this is our lot, so what we usually do here is we divide this lot into triangle. So what we usually do in computing the area of this entire lot, so we divide or we compute the area of this triangle and the area of this triangle, and then we add, then that would be the total area of the lot. Okay, we simply use the formula, the most common one. We have the area is equal to 1/2, that is let's say this is for this triangle, that is the side E times the side D times the sine of the angle in between, that is sine alpha. Okay, now for this triangle, so we come up with this equation: A is equal to 1/2 A times B sine of beta. Okay, so this is the most common used method in computing for the lot area. However, if we have 5 or more sides, so it might be very difficult for you to compute for the area because this could be divided into several triangles and we have missing data here. Okay, so in computing for the lot area, we have useful or easiest approach. We have double meridian distance and we have double parallel distance. This has been used by engineers, by geodetic engineer in computing area, especially if you have 5 or more sided lot. Okay, so let's try to solve an example using either DMD or DPD. Now, if you are familiar with a land title, so you can actually find this data on the land title itself. Okay, and this data here explains the position of your lot, the boundary of your land, the directions, the distances, and so on. And these are the data that a surveyor collects now when they are doing surveying on your land. Okay, so ito yung mga hinahanap na data, especially when you want to sell your land or if you want to divide your land. Okay, so what are these data? So the first column here, this is the line or the boundary, where A and B here, these are points. So basically, when you see line AB, that is the line in between A and B, and we have the bearing, which shows the direction of the line connecting point A and point B, and the distance in between. Okay, so and we have also BC to EA. So if you want to draw the lot using the data given, so this should be the position in which we have 5 points here. We have point A to point B from the data, that is 44.47 meters, and the direction from A to B is southwest. And then we have line B to C, the distance is 137.84 and the direction is northeast. Then we have the line CD having a distance, having the length of 2.83 and the direction is northeast. Then we have D to E with a 64.86 meter distance and with a direction of northeast as well. And the last line, we have E to A having a distance of 107.72 and the direction of A from E is southeast. Okay, so this is how you draw the land using the data given. Now in computation or in computing for the land area using either DMD or DPD, then we compute first the latitude and the departure of each line. Now, what is latitude and the departure? Now, if you try to draw line AB with using this data here, we have, if this is our point A and point B, so the direction is south 46 minute west. So if that is southwest, then therefore that is on the third quadrant of our compass. So basically this would be our line. So from A to B we have southwest. Again this is south, this is north, this is east, and this is west. So southwest, that is on this side. The angle here, let's say that's our angle beta, then to B. Okay, so the latitude here, that is the vertical component of our land, or of our line AB. So basically our latitude here is this line. That's the vertical component, that is the latitude. And departure there, that is the horizontal component of our line. Let's say this is our line, this one is the departure. So as what you can see, we drew a right triangle, correct? So that is a right triangle in which the angle here is our bearing. Again, bearing angle always refers from the vertical side, or it's either from the north or from the south. Okay, so this side here is our latitude, and this side here is our departure, and this one is the distance. Okay, so this from A to B. So we should compute the value of our latitude and departure using trigonometry. Okay, so upon looking at the right triangle, then we can actually compute latitude here using cosine. Okay, from the mnemonic SOHCAHTOA, in which cosine there is adjacent over hypotenuse, correct? So we can say that cosine of the bearing angle beta is equal to the adjacent. The adjacent of beta here is the latitude over the hypotenuse. Now, hypotenuse of our right triangle is the longest side, and we have the longest side here, which is the distance, this one. Okay, that is the line opposite of our 90-degree angle. Okay, so therefore over the distance, so we can say then that latitude is equal to distance times the cosine of the bearing angle. Now, latitude here can either be north or south line or south meridian. Now, take note for our sign convention, if it is a north meridian, then we can say that that is a positive latitude. If it is a south meridian, then that is a negative latitude. So remember this sign convention. For the departure, we can use sine here, that is sine beta is equal to the opposite, that is the departure, over the hypotenuse, which is the distance, correct? So therefore, we can say then that departure is equal to distance times the sine of the bearing angle. So departure can either be the east or the west. So if we have an east, that means that it's a positive departure. If that is west, that means that it's negative departure. Okay, so this formula here are used to compute for the value of our latitude and departure respectively. Okay, and that is for each line. So let's begin computing the latitude and departure from our first line, which is AB. So we have for our line AB, latitude is equal to, the distance of our line AB is 44.47 meters, correct? Then cosine, the bearing angle is 36 degrees 46 minute west, and that would give us 35.624 meters. And for departure, we have departure is equal to 44.47 sine of 36 degrees 46 minutes. So we have here 26.618 meters. Okay, so we write that on our table. So latitude here is 35.624 meters, and our departure here is 26.618 meter. Now, what would be the sign of our latitude and departure? Now, let's refer to the direction of our bearing. Now, take that we have south, west. So, therefore, our latitude here, since we are referring from the south meridian, so that means we have negative latitude. And for departure here, since we are referring on the west, therefore, we have negative departure. Okay, so that should be the sign if we have south and west direction respectively. Okay, they are always negative in value. So you solve latitude and departure using your calculator. But if you are using a Casio calculator, we have a calculator technique. Okay, we can apply some of important features in our calculator. Let's say if you have this type of calculator, okay, so you can use or you can compute latitude and departure here by just using this direct feature, and that is on the minus sign of your calculator. If you are using a Casio calculator, you just click shift and then the minus sign, then we have direct here, then you write the distance. We have 44.47. You input the distance, then comma here can be found on the close parenthesis button. So we have shift, then close parenthesis, then the angle 36 degrees 46 minutes. Okay, then press the equals button. Then we have these two values here. We have the x value and the y value. Now take note, if you are using your calculator, we have different convention. Okay, since we know that latitude here should be the vertical axis or the y-axis on our compass, but in our calculator, the latitude here is given as the x value. Okay, this is supposed to be the y value, but the orientation of our calculator is different. Okay, since the angle here refers from the horizontal axis. Now, if you are again using your calculator, so the x value here, this one is the latitude, and the y value here, this one is the departure. Okay, so we have negative values. Okay, since we have southwest, so we can determine the latitude and departure for the remaining lines. You can use either this formula or you can use your calculator. So let's use calculator na lang to make it fast. Now we have now the value of the latitude and departure for all the lines in our closed traverse, and we can use this again. We can compute latitude and departure here either by using this formula or by calculator technique. Okay, now take note of the sign. We have positive latitude here since we have north, negative departure here since we have west. Now on line CD we have positive latitude since we have due north latitude, and for our departure we have positive since we have due east departure, and for DE since we have northeast, that would give us positive latitude and positive departure. But for line EA, since we have south here, south meridian, that would give us negative value of our latitude, and since we have east here, our latitude, our departure here is due east, that means we have positive value in our departure. Now to check for error of closure, we just need to sum up all the values of our latitude and sum up the values of our departure, and this would give us the summation of all latitude is 0 and the summation of all departure equals to 0 as well. So that means we do not have error of closure. Now in case now we have error of closure, that would be the time that you apply corrections or adjust the data using compass rule or transit rule. Okay, so we have now the value of our latitude and departure. So we can now compute the area using either DMD or DPD, but this time I will be using first DMD or the double meridian distance. So we have another column here, let's say that is DMD. Okay, so in DMD, now for DMD method, the first rule here or the first procedure is copy the value of the first departure. Now, the value of our first departure here is negative 26.618. So, we copy negative 26.618 here. Okay? Then, the next step is add the DMD to the equivalent departure, then the departure of the succeeding line. Okay, so we add negative 26.618 plus the departure of the same line. So we have plus negative 26.618, then plus the departure of the succeeding line. We have plus negative 115.842. Okay, so you add, this would give us the DMD value for the line BC. This would give us negative 169.078. Okay, so we have negative 169.078. Now, to compute for the DMD of the next line, so the same rule, we add the DMD negative 169.078 plus the departure of the same line, this one, then plus the departure of the succeeding line, which is this one. So you add negative 169.078 plus negative 115.842 plus 0.392. This would give us negative 284.528. So again, the same procedure, you add this DMD plus this departure plus this departure, then that would give us negative 222.392. And lastly, we have negative 80.324. Okay? So you have now the value of DMD. Now, we compute for the double area. Okay, that's the double area, or 2A, let's say. Now, to compute for double area, you just multiply this DMD and the value of the latitude of the same line. So, we multiply negative 26.618 times negative 35.624. This would give us 948.240. Okay, and since this area, so we have meter squared. Okay, that is the unit. So the same procedure for the next line. So we have negative 169.078 times 74.703. We have here negative 12630.634. So the same procedure for all the remaining lines. So we multiply DMD and the latitude of the same line. Then we have the values. So we have here the values of double areas for every lines in our closed traverse. And then we add all these areas here. So we add 948.240, negative 12630.634, then negative 3648.787, the negative 4417.372, and 5765.335. That would give us the value of our double area, which is, we have the answer negative 13983.203 meter squared. Now take note, this is double area. To compute for the area, then we divide it by 2. So we divide it by 2. We divide both sides by 2. Then we have the value of our area of our lot, which is equal to negative 6,991.602 meters squared. Since we do not have negative area, then we can actually eliminate negative na lang. So therefore, our area is equal to 6,991.602 meter squared. Now, to compute for hectare, now we know that in 1 hectare, this equivalent to 10,000 square meter, correct? So this means that the total area in terms of hectare is, we divide it by 10,000, that would give us 0.699 hectare. Okay, so this is our answer. In computing for the area, so we use either DMD, the double meridian distance, or the DPD, or the double parallel distance. But this time, I will be using DPD. So we add another column here, then we have the DPD value, or the double parallel distance. Now, the first procedure in DPD is that we write the first latitude of the first line. Now, in line AB, the latitude is 35.624. So we write negative 35.624, and this is in meters. Okay? Now, the next step is you add the value of the DPD and the latitude of the same line, then add the latitude of the succeeding line, which is this one. Okay, so you add negative 35.624 plus negative 35.624 plus the latitude of the succeeding line, which is 74.703. Okay, so this would give us 3.455. So using the same procedure, we add 3.455 plus the latitude of the same line, which is 74.703, plus the latitude of the succeeding line, which is 12.824. So we have 3.455 plus 74.703 plus 12.824. This equals to 90.982. So using the same procedure again, then we have the DPD value for line DE, which is 123.669. For the line EA, we have 71.756. So we compute now the double area. Okay, this is in terms of square meter. To compute for double area, this basically equal to DPD times the departure. Okay? In contrast with DMD, or double meridian distance, the 2A here, or double area, is equal to DMD times the latitude. Again, this is for the DMD. Okay, since we are using DPD, so we multiply negative 35.624 here, and the departure, negative 26.618. This would give us 948.240. Then we multiply 3.455 and negative 115.842. We have here negative 400.234. Now we have 90.982 times 0.392. This would give us 35.665. Then we have 123.669 times 61.744. Then we have here 7635.819. And lastly, we have 71.756 times 80.324. This would give us 5763.729. Now, to compute for the area, we sum up this value here of our double area, then we divide by 2. So we add all this value. This would give us 13983.219, that is square meter. Now take note, this is still double area. So to compute for the area, we divide it by 2. Okay, so if we divide it by 2, then we have the answer 6991.610 meter squared. Okay, as what you notice, we have the same answer using double meridian distance. Okay, so DPD and DMD should have the same answer. Now, take note again, since some of area are in terms of hectares, so we have to divide it by 10,000 to compute for its value in hectares. So we have here 0.699 hectares. Okay, so this is the area of our lot using DPD. And that ends the discussion on area computation using DPD and DMD. Now, if you have questions, you can comment it down. Please don't forget to subscribe to my channel for more videos. Please hit the notification bell. Thank you guys for listening, and God bless.